Lost in space. Contact has been lost with a spacecraft carrying an experimental quantum drive. Can you believe it? Like I said, Earth is amazing. Not just the places, but the people. Look at what we've done now. Breaking barriers and the laws of physics. Welcome back to another episode of Focus. Thanks for joining. Contact lost with a spacecraft carrying an experimental quantum drive. Dead on arrival. Quantum of Solace. A test involving a highly controversial propellantless propulsion system called the quantum drive has failed because the satellite it was aboard fell silent, the debrief reports. In a press release, Rogue Space Systems explained that its Barry 1 CubeSat, ferried to orbit by a SpaceX Falcon 9 rocket, was plagued with ongoing power system issues. A test with the quantum drive developed by IVO Limited was supposed to demonstrate whether the engine could alter the orbit of the satellite, but for some reason, after 2 months in orbit, the test was never even initiated, and contact with the satellite was lost on February 9th this month, and an unceremonious end for a demo that was supposedly going to upend the laws of physics. Rogue's Barry 1 satellite didn't make it all the way through LEOP, launch and early orbit phase. IVO founder and president Richard Mansell told the debrief, "Sadly, we never even got to turn on the drives." Had the test actually been conducted, skeptical scientists, and there are many, believe that the quantum drive wouldn't do anything. That's because it's a type of engine known as a reactionless drive, in which a reaction mass, essentially the propellant, is not used to generate thrust. According to Newtonian physics, such a device wouldn't work because propulsion without a propellant is impossible. Nevertheless, IVO claimed that its quantum drive could generate an eyebrow-raising 52 millinewtons of thrust per 1 watt of electricity, which is a ludicrous 12 times more efficient than existing ion drives used on satellites, Forbes noted. It's an appealing idea. The problem with propellant is that the stuff runs out. It's also heavy, taking up a significant portion of a spacecraft's weight, which not only comes with its design limitations, but drives up launch costs. And so there's been a lot of excitement and controversy over lab tests that claim spacecraft could ditch propellant by harnessing spooky properties of quantum mechanics. But so far, none of them have been borne out in large-scale tests, let alone ones conducted in space, of which, according to the debrief, IVO's test would have been the first. Another crack. Undeterred by the setback and seemingly the laws of physics, Mansell said that IVO will be conducting further orbital tests with its quantum drive. The overall configuration of the drives will not change. He told the debrief, "While waiting for the Barry 1 test, we have been continuously working to improve the drives. Those improvements will be part of the next set that goes to space." It has to be said, it seems a little convenient that the CubeSat went bust before the quantum drives could even be activated after waiting for 2 months in orbit. But hey, maybe they'll remember to turn the thing on next time and, fingers crossed, even manage to prove physics wrong. Like I said, Earth is amazing, and a story like this I find even more amazing. Do you think it would work? Like I said, Earth is amazing, not just the people, not just the places, but what we have done with it and what we have yet to do with it. Thanks for sticking around and joining for another episode of Focus. I hope you have a great day and take care. Thanks for sticking around for the thoughts and facts section. Let's start with a little about the company in question, IVO. Apologies. So, they say their ambition is not only to push the bonds of modern technology, but to also place the innovator and inventor into an atmosphere where the impossible can be made possible. This world is ever changing, and with change comes new opportunities and possibilities for technology. Since I began my role as Chief Executive Officer of IVO Limited in 2018, it has become irrefutable that the technology world is changing without addressing major issues. IVO Limited is making these issues its priority. The preservation of our great planet will not be achieved with the creation of toxic batteries and unsafe charging technologies. That is why I have focused our company's energy into advancing wireless energy transmission solutions. This type of innovation only happens in an atmosphere where we can challenge the very foundation in which energy transmission has been built upon. On behalf of IVO Limited, we accept this challenge. And that is the testimony of Richard Mansell, the Chief Executive Officer. So that's who the company is. How about a little bit about what is a quantum drive? I know it sounds straight out of sci-fi, but it's actually based on something called the quantized inertia, or the QI theory. So the quantized inertia theory is a theory of inertia first proposed in 2007 by physicist Mike McCulloch from the University of Plymouth. The phenomenon of inertia is defined in Newton's first law. Objects move in straight lines at constant speed unless pushed on, but it has never been explained. Quantized inertia explains inertia for the first time by combining relativity and quantum mechanics. According to relativity, an accelerating object will see a Rindler or a Reindler horizon in the direction opposite to that of its acceleration vector. This is because information travels at the speed of light. Quantized inertia further predicts that for objects with very low accelerations, such as stars at the edge of galaxies, the Rindler horizon moves so far back that it is close to the cosmic horizon, so the waves of Unruh radiation are now damped equally all around. And the mechanism of inertia collapses. This explains why stars at the edge of galaxies can orbit faster than expected but still remain bound to the galaxy. As a result, quantized inertia predicts galaxy rotation perfectly without the need for dark matter or any adjustments. More practically, quantized inertia also predicts that we can get thrust and energy from the vacuum. An accelerating object will see itself surrounded by so-called Unruh radiation. The horizon splits virtual particles, so they become real radiation. Quantized inertia combines these two predictions by saying that the horizon damps or reduces the Unruh radiation on one side of the object. The resulting gradient in the quantum vacuum pushes the object back against it, which basically, causes the acceleration, explaining inertia. But the company received a patent for a capacitor used in the wireless transmission of power, a primary market for IVO's commercial endeavor that includes the CBAT wireless transmission system, currently undergoing strict FCC testing for certification. But the company's main ambition is how do they say it? A zero fuel it's zero fuel, infinite possibilities. So the IVO quantum drive is the world's first pure electric propulsion technology tested and validated to low Earth orbit environments. And as far as they're concerned, and if you know your stuff, this would definitely be the future of space propulsion. But what could this actually mean for us? Using a technology like this could do away with nuclear power. And I only say that in the sense of for long-range transmissions, because right now we have been, throwing up in the air or putting pen to paper or marker to the drawboard and coming up with all of these nuclear-powered spaceships in an effort to reduce the cost of propulsion. And if not, the fact that batteries can become tricky and cause problems, they amount to what you would call a single point of failure. So in terms of a spacecraft operating in the zero gravity, minus degree temperatures of space, you need something a little more reliable. So being able to simply convert the power generated from a solar panel straight into this quantum drive, even the way it works is quite unique, I would say. If they do manage to pull this off, yes, we have many technologies, many things we can do. Lead obviously can dampen the radiation received or emitted from certain things. So theoretically, if you pad or you line one side of this craft with enough lead, lining or something similar, just to cause this effect or prevent the excess radiation, as it said, from escaping on the other side of the object, or in this case the craft, could be significant. We would still have to use propulsion or propellants to get into orbit at least. But once we are there, we won't have to expel any propellants in order to do stuff like adjusting the orbit of satellites or space stations. The current International Space Station right now, as far as I'm concerned, is in a sorry state. And the only reason I say this is because NASA, as brilliant as they are, see the only viable option to it in its current state to be deorbiting the spacecraft itself, the entire station. To deorbit it means to control its re-entry into Earth in a way that would hopefully allow it to disintegrate, or allow as much of it as possible to disintegrate without harming anyone or anything, or Earth in general. There have been other ones that involve towing it into a higher orbit, but that in itself is an entirely different thing. If a technology like this could actually come into fruition, it's not only going to change how satellites and space stations operate in space. Yes, it's going to completely revolutionize the space industry, and if anything, what's in a really poor condition right now, our atmosphere, or not our atmosphere, low Earth orbit is in a sorry state. The amount of debris, old satellites, and leftover, or you call it rocket stages, from the multiple rocket launches that have been carried out from the beginning of space tech, or space flight. So even having something like this on a craft that could then also theoretically fly around and pick up the majority of this debris in space, I mean, the ramifications, and when I say ramifications, I don't mean it in a negative way. I mean the way this could help revolutionize the space industry. It could make it not only more affordable, more efficient, it could actually make it safer. It could actually make it more economically viable. It could actually make it more planet friendly, which is the main goal, as the Mr. Mansell said. But a quantum drive, can you believe it? Everything now is only how it can help us in the immediate sense of the word. Imagine how this could help us in future exploration of the galaxy. And I know I'm getting ahead of myself, sometimes I always do, but a drive that can run on pure electric means not only we can explore the galaxy, and I don't mean this in the sense of sending people on spacecraft on endlessly long journeys, possibly never to return. I mean, we could send out now satellites, probes that could run further than Voyager and be able to adjust its trajectory, which, if you don't know, is the problem with Voyager. I mean, we can't really control much of what's going on with it right now. But imagine if we could send a probe with a quantum drive attached to it. The amount of time it would take it to reach the same distance Voyager has reached from our planet could be cut in half. In fact, it could be a third of the time. What could that mean for us as a species? Instead of having telescopes like James Webb, or like we used to have the Hubble, we could actually send probes out to some of what we call these exoplanets. Some of these, primordial oozes. We could send it to the pillar of creation. Could you imagine that? What if we could get a probe all the way there? What do you think that would look like? It could happen in our generation. It could happen in our lifetime. Hey, you never know. Like I said, we're making history pretty fast, and our history is pretty vast. I always promise to keep it brief, but in the grand scale of it all, it's all subjective. We've been around for millions of years, so what's 13 minutes of your time? I'm sorry. Thank you very much for tuning in and sticking around and sharing a moment of your time with me. And welcome back, and thanks for tuning in to another episode of Focus. Take care, have a great day, and like I said before, it's always time to make it happen. See ya. For links to the articles, check out the episode description. If you want to leave a comment, check out the trailer description for the email address. For topics like these and more, check out future episodes. Like I said, the world is an amazing place. There's a lot going on, and sometimes we just need to take a moment to focus.